Okay, today we're going to talk about, Today we're going to talk about observational methods. That's the wrong one. We're going to talk about chapter 7, chapter 8, and chapter 9. Okay, there we go. Okay, measurement, chapter 7. Measurement is defined as a procedure whereby a researcher assigns numerals or other symbols to the empirical properties of variables according to a prescribed set of rules. Three basic concepts to define measurement. Numerals are symbols that are given quantitative meaning and then become numbers that make possible the use of mathematical and statistical techniques for purposes of description, explanation, and prediction. One of the things that we do in social sciences, we give numbers to just about anything. So let's say we think somebody's depressed. We put a number to it. On a scale of 1 to 10, how depressed are you? With 1 being not depressed at all and 10 being uh, very depressed to the point that I want to commit suicide. That's how you do it. And we do this with just about any concept that you can think of. Assignment refers to the mapping of symbols onto objects or events. Rules explicate the ways in which numbers or numerals or numbers are to be assigned to objects or events. And of course, that's the biggest problem. When I did my research, I was doing research on resilience. You can imagine trying to put a number to resilience. But of course, I was able to do it because there was an instrument that actually quantified resilience. It was really kind of interesting. It's not the only instrument out there. There are other instruments that also quantify resilience. Rules are the most significant component of the measurement process because they determine the quality of the measures taken. And this is one of the interesting things about psychological research. If you look at psychological research, if you read a lot of journal articles, one of the things that you're going to discover is that people use the same instruments over and over and over again. And the reason they do that, like Beck's depression inventory, one of the reasons that they do that is because that has already been quantified and it's already been shown to be something that actually measures what you say it measures. There are various journal articles that talk about how strong this measurement is, and those are part of the rules that we're talking about. If I wanted to come up with a concept of depression, a new measurement of depression, I would have to prove that it actually measured depression. The function of rules is to tie the measurement process to reality, and of course that's what I was just talking about. Isomorphism is a mathematical term that means similarity or identity of structure, and determining whether a measurement procedure is isomorphic. The central question concerns not just the degree of congruence between the particular numerical system that is being used and empirical reality, but also the concept being measured. Social scientists measure indicators of concepts, and often multiple indicators must be developed to represent abstract concepts. As I've told you before, when I did my research, I was looking at culture. Now, how in the world do we measure culture? How do we do that? What does that look like? And in the case in the case of my research, I used an instrument that measured how culturally aware an individual was. Now, where in the world did this thing come from? Well, it actually wasn't developed looking at Native Americans. It was developed looking at Hispanics and looking at African Americans and looking at Asians and looking at the white population. But it had been used to measure the cultural awareness of different American Indian groups. And because of that, and because I was able to show that it had been determined accurate by other researchers, I was able to use that measurement. Indicators are terms used to refer to a concept. Indicators should be grounded in both theory and empirical observation. Indicators are used to measure a concept. They should derive from theories and practices of that concept. And of course, the example to the right, economic giant or social pygmy. What do we look at? Do we look at infant mortality rate? Do we look at access to improved sanitation, life expectancy at birth, mean year of schooling? Are these what we're looking at when we're trying to determine whether somebody is, whether a country is an economic giant or a social pygmy? Female literacy rates, as you can see, India has a female literacy rate of 74. Myanmar has 96 and Bangladesh 97. Male literacy rate 88, 96 and 97. As you can see, India, Myanmar, and Vietnam. So anyway, so these are all indicators. These are all indicators of whether somebody is going to be whether a country is going to be an intellectual giant or whether it is going to be a social pygmy. The concept of democracy can be represented by several different indicators. Of course, this is coming up right now because of the upcoming presidential election. Are the elections going to be fair? What happened in the last election? The Russians interfered with the election. President Trump didn't like it, but they backed him. The Russians backed him, and of course he's been arguing that he won fair and square throughout his presidency. But the question comes up: will the elections be fair? Of course, he's bringing up the idea that we can't use mail-in ballots because they're too easily they're defrauded. They may not be accurate. Okay, fairness of elections. That has to do with democracy. Degree of competition between political parties. How competitive are the Democrats and Republicans? Well, if you read the news every day, then you see that the Democrats are saying one thing and the Republicans are saying something totally different. The Republicans would like to see the economy open up after COVID-19, and the Democrats are saying, wait a minute, what's more important, people's lives or the economy? And the Republicans seem to be saying the economy is more important than people's lives, and the Democrats seem to be saying that people's lives are more important than the economy. Well, some people probably agree. Well, if you think the economy is more important than somebody dying in Florida, then you're going to agree with the Republican Party. Where is he today? Where is Trump today? He was in Florida yesterday. Oh, he's at Walter Reed Hospital today in Washington, D.C. Freedom of the press. One of the interesting things that has happened since Trump was elected is there has been a huge argument going on between conservative media and more liberal media. And of course, the president is conservative, so he has been trying to say that the liberal media should be stifled, and the conservative media should be listened to more readily. Of course, if you're conservative, you listen to the conservative media. If you're liberal, you listen to the liberal media. But the freedom of the press is very important as far as democracy is concerned. The freedom of to organize and the rights of minorities. And of course, this is since George Floyd's murder in Minneapolis, this has come to the fore in most of the cities in the United States. Minorities are saying we are. This isn't equal. We don't have the same rights as white people do. And there you go, concept of democracy. There are 4 levels of measurement: nominal level, ordinal level, interval level, and the ratio level. I'm going to explain them all right now. The nominal level is the simplest level of measurement. It functions solely for the purpose of classification. Symbols are used to classify objects or events into categories. Nominal level is used when the properties of a variable can be classified into a set of categories that are both exhaustive and mutually exclusive. Okay, so gender is one of the examples of a nominal scale. Of course, if you look on Facebook, gender has, I guess there's 56 different categories of gender, not just male and female anymore. Hair color, of course, I guess this means your original hair color. Some people have blue hair and some people have red hair and orange hair and all kinds of interesting colors. Anyway, hair color, as you can see, they misspelled color because this is from England, and England spells color with a U. Ordinal level measurement allows for classification and also degrees within that classification. Examples: productivity, socioeconomic status, democracy, intelligence, education, motivation. They're all examples of ordinal levels of measurement. Whenever a phenomenon or process has a range, such as greater than or less than, highest or lowest, etc., you have an ordinal measurement. How do you feel today? Very happy, happy, unhappy, okay. Oh, I'm sorry, I'm reading it from the wrong direction. Okay, very happy, happy, okay, unhappy, very unhappy. How satisfied are you with our service? Very unsatisfied, somewhat unsatisfied, neutral, somewhat satisfied, very satisfied. Those are all ranges, so that's all ordinal. Interval levels of measurement rank a set of observations in terms of the relation and also the exact and constant distance between each of the observations. In addition to saying that one object is greater than another, you can now specify by exactly how many units the former is greater than the latter. Interval data need a precise unit of measure. Examples would be income. And how do we measure income? By dollars. How many dollars did you make last year? Intelligence, we have IQ scores. Scholastic aptitude, we have SAT scores. Voter turnout is absolute. A select number of people voted in the last election. And crime rates, how many crimes were committed over a select period of time. And of course, this is an example of prevalence of anemia in children under 11 years of age in Mexico in 1999. And all of this is absolute. How did they measure it? They looked at hemoglobin adjusted to altitude using the equation proposed by Ruiz Arguelles. Anyway, hemoglobin. And of course, this all makes a lot of sense to me because I used to measure hemoglobin, and at different altitudes, the higher you are, the thicker your blood, as strange as that may seem. The thinner your blood. Anyway, has to do with altitude. So now that I'm in, where am I? Now I'm in Lost Nation, Iowa. My blood is actually thicker than it was up in Saley, because Saley's at 7,500 feet, and now I'm at 400 feet. So my blood is thicker down here than it was up there. Ratio level data are variables that have absolute and fixed natural 0 points that can be measured. A ratio level of measurement is achieved only when it is possible to attain all 4 of these relations: equivalence, greater than, known distance of any 2 intervals, and true 0 point. In the social sciences, this might translate into length of time migrant workers typically stay at a single job site, number of community affiliations, number of occupations held by a certain age. Examples would be your weight, the time that somebody spent someplace, and the length of something. Those are all absolute numbers. Due to the precision of numerical measures used on the ratio scale, the ratio level, highly powerful statistical manipulations can be performed on these values. And as you can see, the percentage of Democrats, Republicans, and others, 33% are Republicans and 44%. I don't know when this was. Anyway, as you can see, there are more Democrats than Republicans. Variables that can be measured at the ratio level can also be measured at the interval, ordinal, and nominal levels. As a rule, properties that can be measured at the higher level can also be measured at lower levels, but not vice versa. Differences in scores that are due to anything other than real differences in the aspects of the property being measured are termed measurement errors. Common sources of measurement errors: the scores obtained may not be related to the attribute the researcher intended to measure, but to another associated attribute. Temporary differences in conditions such as health or mood, which may affect a person's responses or behavior. Differences in the setting in which the measure is used. Differences in the administration of the measuring instrument, poor lighting, noise, tired interviewers. Differences in processing. Different people interpret the measuring instrument in different ways, and that can all cause measurement error. Systematic or random errors. Systematic errors occur whenever the measuring instrument used consistently introduces a degree of invalidity to all findings. Random errors, by contrast, affect each instance of measuring instruments use in a different way. The seriousness of the issues of validity and reliability prompted the development of techniques for reducing measurement errors, because there are measurement errors in a lot of different social science techniques. Validity is concerned with the question, am I measuring what I intend to measure? The problem of validity of the measurement is an outgrowth of the nature of the variable studied. There are three basic types of validity: content validity, empirical validity, and construct validity. Content validity: the measurement instrument covers all the attributes of the concept you are trying to measure. There are two common types of content validity: face validity and sampling validity. Face validity rests on the investigator's subjective evaluation of the appropriateness of the instrument for measuring the concept under study. The main problem is that there are no precise replicable procedures for evaluating this type of content validity. It is difficult to repeat the evaluation procedure precisely when the researcher has to rely entirely on subjective judgments. Sampling validity: the researcher develops an exhaustive list of all domains of the concept under study, then develops a measurement instrument, for example, a questionnaire in which each of these domains is represented. Ascertaining sampling validity serves an important function. It calls for familiarity with all the items describing the content population. Empirical validity is concerned with the relationship between a measuring instrument and the measured outcomes. Scientists assume that if a measuring instrument is valid, the results produced by applying the instrument and the relationships existing among the variables measured in the real world should be quite similar. If a measuring instrument is valid, then there should exist strong relations between the results produced by the instrument and other variables. An example would be an educator seeking proof that IQ scores of individuals actually reflect intelligence. And of course, there are ways of trying to determine this, and we're going to talk about that. Predictive validity is the degree of correlation known as the correlation coefficient between the results of a given measurement and an external criterion. An example: an investigator can validate an intelligence test by obtaining the test scores of a group of college students and then obtaining the grade point averages that these students achieved in their first year of college. The researchers then compute a correlation coefficient between the two sets of measurements. The resulting correlation coefficient is called the predictive validity coefficient. Establishing validity of criterion. One method relies on the agreement among researchers that a certain criterion is valid for evaluating a measuring instrument. This agreement is subject to tests of face validity and sampling validity. A different method involves determining the percentage of units of analysis that would be classified correctly by the instrument according to their known characteristics, and expressing the relationship between the instrument's measured outcomes and the criterion in terms of a percentage. Construct validity is established by researchers by relating a measuring instrument to the general theoretical framework within which they conduct their studies in order to determine whether the instrument is logically and empirically tied to the concepts and theoretical assumptions they are employing. To demonstrate the construct validity of a measuring instrument, an investigator has to show that these relationships can be recognized and measured by their instrument. Measuring someone's temperature with a survey or written quiz has no construct validity. Lee Cronbach and Paul E. Meehl describe the logical process of construct validation in the following order. A scientist suggests the proposition that an instrument measures a certain property, say property A. They insert the proposition into a theory regarding property A. In working through the theory, the investigator predicts which properties should be related to the instrument and which should exhibit no relation to the instrument. He or she collects data that will empirically confirm or reject the predicted relations. If the anticipated relationships are found, the instrument is considered valid. If the predictions are rejected, the explanation for the failure to do so lies in at least one of three possible causes. The instrument does not measure property A. The theoretical framework that generated the predictions is flawed. The research design failed to test the predictions properly. Convergent discriminant conception of validity, or the multi-trait, multi-method matrix technique. This method derives from the idea that different methods of measuring the same property should yield similar results. Operationally, this means that the correlation coefficients calculated from scores for a given property measured by different instruments should be higher than the correlation coefficients calculated from scores for different properties measured by similar instruments. A measuring instrument should be examined for all three types of validity. First, evaluate the theories that should serve as foundation for the instrument. This is construct validity. Next, define a content population of items from which a representative sample is to be drawn. This is content validity. And finally, assess the predictive power, the empirical validity of the instrument by relating it to an external criterion. Reliability refers to the extent to which a measuring instrument contains variable errors, that is, errors that appear inconsistently between observations either during any one measurement procedure or each time a given variable is measured by the same instrument. If you measure a board with a tape measure and get 12 feet 6.5 inches one time and 12 feet 6.25 inches the next time, the tape measure has a variable error. Social science measures tend to be less exacting than physical measures, so variable errors are not only somewhat common, but expected. This would be something that we would see if we were measuring depression. How in the world do you measure depression, and is the Beck's depression inventory accurate? That's the question that you have to determine. If somebody commits suicide and they just took the Beck's depression inventory and they scored low on the inventory, does that mean that the Beck's depression inventory doesn't work since they committed suicide? Since variable errors are so common in social science measurements, the researcher must anticipate seeing an observed score and a true score anytime an experiment is done. In order to correct an observed score to a true score, the researcher must adjust the observed score using a statistical formula to calculate variance. Estimating the reliability of an IQ test, we need to think about the discrepancy between observed scores, xi, and true scores, ti, for all persons who took the IQ test. To do this, we calculate a measure called the variance. This involves taking the IQ score for each person, xi, and subtracting this from each of these scores, the average IQ score across all persons who took the test, x bar. Since some of these quantities, xi to x bar, will be negative and others positive, we then square these differences so that they are each positive. And of course, that shouldn't be in there. That doesn't make any sense. Anyway, so what we do is we take each score and we subtract the mean score from it. And then even if it's a negative score, we square the thing, we square that number, and that gives us a positive number. So we add up all the positive numbers. We're going to do that in a minute. We then add up these results and divide through the total number of test scores in. So if we were looking at 100 IQ tests, we get the mean for that IQ test. We'd subtract it from all of the results of each individual. That means we're going to have 100 numbers. Some of them will be positive and some of them will be negative. We will square all of those numbers and then we will divide by n, by the number. And the number, of course, is 100. Thus, the formula for the variance can be written like that. And I'm not going to talk. Okay. We must consider that the variance can be calculated for each of the n components, for the distribution of observed scores, true scores, and errors. These three variances are then used to generate a reliability measure of IQ. We see that if our measure involves nothing but error, the measure of the reliability will be 0. So the reliability is a score between 0 and 1. Conversely, if our measure is entirely devoid of error, the measure of the reliability will be 1. Thus, reliability ranges on a scale from 0 to 1. Not only but the closer to 1 it is, the higher the reliability. The closer to 0 it is, the lower the reliability. In practice, all that researchers have to go on are observed measurements. The true component and the error component are unobserved. As a result, these components must be estimated. Generally there are three methods to estimate the reliability. And that is the test-retest method, the parallel forms technique, and the split half method. Ooh, it's getting dark outside. We're in the middle of a thunderstorm. Test-retest method derives directly from the conceptual definition of reliability. The researcher administers the same measuring instrument to the same group of persons at 2 different times, and then proceeds to examine whether the 2 sets of scores covary with one another. Error is defined as anything that causes a person to obtain a different score on the 2 set tests. Test-retest limitations. A measurement taken on one occasion may influence or condition the measurements taken on subsequent occasions. Since many phenomena change constantly, it is possible that changes may have occurred within the period between the 2 tests, the measurement interval, thus lowering the obtained estimate of reliability. The test-retest method then may either overestimate or underestimate the true reliability of the instrument, and in many cases, it is simply difficult to determine what has occurred. Parallel forms technique. A researcher develops 2 parallel versions of a measuring instrument. Both versions are given to the same group of persons. The researcher examines the covariation between the 2 sets of scores. With this technique, however, the problem arises as to whether or not the 2 versions of an instrument are in fact parallel. So an example would be I don't trust you guys, so I give you two tests just in case somebody's giving everybody the answers. I give you two tests, and theoretically each test is equal, but there's always a possibility that one test is harder than the other test. And wouldn't it be unfair if you were the one taking the harder test and somebody else got to take the easy test? Split half method estimates reliability by treating each of two or more parts of a measuring instrument separately. An example dividing a questionnaire into two parts, such as odd numbered and even numbered questions. Each of the two sets of questions is treated as a separate questionnaire and scored accordingly. The researcher then examines the degree of covariation between these two sets of results. Generalizability is the extent to which the research findings can be generalized to larger populations than were tested and applied to different settings than the setting for the initial research. My research was on the Northern Plains. It was with a select group, select tribe or select tribes actually. But could I generalize that to the other 6 reservations in Montana? And the answer is no. I couldn't do that. I tested a specific group of individuals. I was looking at them, looking at their resilience, and I couldn't generalize that to the Crow tribe, which is also up there, the Cheyenne, Northern Cheyenne. There's several groups of Sioux, Lakota, and Dakota, Nakota. I'm sorry. There's the mountain tribes, and of course I couldn't generalize it to those individuals. So certainly I couldn't generalize it to all American Indians. I couldn't generalize it to the people in the Southwest. And that is the end of Chapter 7. So let's start with Chapter 8, Sampling and Sample Designs. This is something that we just went over in statistics. I'm helping my son teach the statistics class, so if you're in one class, you're going to be hearing the same thing in this class as that class. The population is the complete set of relevant units of analysis or data. The sample is a subset of the population. Parameter is an attribute found in the population that can be measured. And when I was doing my research, of course, I was looking at resilience. I was looking at age as compared to resilience and education and whatnot. Those are all parameters. All the variables are parameters. Sampling theory is objective its objective is to provide the basis for making accurate estimates of the unknown values of the parameters based on calculated sample statistics. To estimate unknown parameters accurately from known statistics, researchers have to resolve 3 major problems. First, they have to define what their population is. If we're talking about all the people in the United States, that's our population. Then we may talk about the sample design. What is the sample? If our target population is everybody in the United States, our target sample may be everybody that votes. That's fairly normal. And how many people are we going to count? That's the size of the sample. I'm wondering if you can hear the thunder. A unit can consist of individuals, communities, people with shared characteristics, cities or counties. Determining your population poses challenges. The population has to be defined in terms of content, all voter eligible Hispanics, extent in the United States, time, November 6, 2012, the date of the 2012 presidential election, which was won by Barack Obama over Mitt Romney. Sampling unit, a single member of a sampling population, a voter, household, and event. Sampling units usually have numerous attributes, one or more of which are relevant to the research problem. A sampling unit is not necessarily an individual. It can be an event, a university, a city, a nation, or even documents. Finite population contains a countable number of sampling units, for example, all the registered voters in a particular city in a given year. Finite infinite population consists of an endless number of sampling units, such as an unlimited number of coin tosses. So finite population would be, well, just as they said, the registered voters in a given year. A sampling frame should include all the sampling units in the given population, but such information is rarely available. Instead, researchers usually have to use substitute lists that contain the same information, but that may not be comprehensive. Sampling frame for smaller studies may be based on telephone directories, city directories, or membership lists of private and public organizations. The researcher has to ensure that there is a high degree of correspondence between a sampling frame and the sampling population. The sampling frame must be evaluated for potential problems, incomplete frames, clusters of elements, blank foreign elements. Incomplete sampling frames are when sampling units found in the population are missing from the list. Solution might be the use of supplemental lists. For example, if the population includes all the new residents of a community from a real estate listing, it might leave out renters. A city directory might be used to supplement the real estate listing, and of course, that way we put the two together. How did I get my population? Oh, I was looking at voter lists, which I wasn't supposed to have, but a friend of mine, friend of mine gave me the voter list for the county, and I took that, and I wasn't using anybody on the reservation. I was just using natives off the reservation. So what I did, I looked for names that were common on the reservation and were off the and had addresses off the reservation. That's what I did. And it was kind of, they were trying to figure out how I got that list. Clusters of elements occurs when the sampling units are listed in groups rather than individually. For example, the sampling frame may consist of city blocks, whereas the study focuses on individuals. One possible solution is for the investigator to take a sample of blocks and then list all the individual households in each of the selected blocks. The researcher then selects individuals from each household according to a specific criteria. Blank foreign elements occur when some of the sampling units in the sampling frame are not part of the research population, such as the case where the research population is defined as eligible voters, but the sampling frame includes individuals who are too young to vote. Solution: these cases should be treated as blanks and simply omitted from the sample. Representative sample, the essential requirement of any sample is that it be as representative as possible of the population from which it is drawn. A sample is considered to be representative if the analyses made using the sampling unit produce results similar to those that would be obtained had the entire population been analyzed. Probability versus non-probability sampling. Probability sample is distinguished by the ability to specify the probability at which each sample unit of the population will be included in the sample. Probability sample makes it possible for researchers to estimate the degree to which the findings based on one sample are likely to differ from those obtained by studying the entire population. Non-probability sample is when there is no way of specifying the probability of each unit's inclusion in the sample, and there is no assurance that every unit has some chance of being included. Non-probability sample is used when a sampling population cannot be defined precisely or when a list of the sampling population is unavailable. The four major designs using non-probability samples, convenience samples, snowball samples, purposive samples, and quota samples. Convenience sample. A convenience sample selects whatever sampling units are conveniently available. A convenience sample cannot estimate the population's parameters from the values of the characteristic obtained from the sample. Snowball samples often are used in combination with convenience samples as a way to sample what is called hard to reach or hidden populations. undocumented migrants, female sex workers, etc. The basic logic of snowball samples is to identify new sampling units such as people by soliciting information from existing sampling units. Researchers are able to increase the number of sampling units available to them in their study. Purposive or judgment samples. Purposive samples require subjective judgment to select sampling units that appear to be representative of the population. Because it is usually difficult to determine why a researcher judges the sampling unit selected as being representative of the sample, it is difficult to determine the probability of the inclusion of any specific sampling unit in the sample. Purposive samples can still be successful, for example, voter polling. Quota samples select a sample that is as similar as possible to the sampling population. For example, if it is known that the population being researched has equal numbers of males and females, equal numbers of males and females are selected for the sample. Group characterized by specific variables such as gender, age, place of residence, and ethnicity are interviewed, and that's a quota sample. Simple random sampling. There are four common probability sample designs: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Simple random sampling is the basic probability sampling design. Simple random sampling is incorporated into all of the more elaborate probability sampling designs. Simple random sampling assigns to each of the sampling units of the population, denoted by the letter N, an equal and known non-zero probability in being selected. Systematic sampling consists of selecting every kth sampling unit of the population after the first sampling unit is selected at random from the total of sampling units. The first selection is determined by some random process, such as the use of a table of random digits. Systematic sampling is more convenient than simple random sampling. Systematic sampling is easier to use with very large populations or when large samples are to be selected. This is the way you selected teams when you're in phys ed back in the 8th grade. You all lined up and you all counted off 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And if you're a 2, then you're in the group with the 2s. That's what kth means. Stratified sampling. Stratified sampling ensures the different groups of a population are represented adequately in the sample. All the other things being equal, stratified sampling considerably reduces the cost of the research. Stratified sampling uses available information on the population to create a set of homogeneous groups based on the variables of interest. Cluster sampling is frequently used in large-scale studies because it is the least expensive sample design. Cluster sampling involves first selecting larger groupings called clusters through random or stratified sampling, then selecting the sampling units from the clusters. The choice of clusters depends on the research objectives and resources available for the study. That would be if you had a professor who is doing research and he used your Psych 1 class, or Psych 111, and tested everybody in the Psych 111 class. That would be a cluster sampling. Fallacies concerning the necessary size of a sample. One is that the sample size must be a certain proportion, often set at 5% of the population. Another one is that an adequate sample size is about 2,000 units. Still another misconception is that any increase in the sample size will increase the precision of the sample results. To determine proper sample size, researchers need to determine what level of accuracy is expected of estimates. That is, the size of the standard error. Standard error is a statistical measure indicating how closely sample results reflect or deviate from a parameter's values. It is calculated from the distribution of all the sample means about the mean of the total of those samples. Standard error measures the level of randomness in the sampling process. The standard error of a sample mean is an estimate of how far the sample mean is likely to be from the population mean. The mean and standard deviation are descriptive statistics. The standard deviation of the sample data is a description of the variation in measurements. The standard deviation of the sample is the degree to which individuals within the sample differ from the sample mean. The standard error of the mean of the sample will tend to zero with increasing sample size, because the estimate of the population mean will improve, while the standard deviation of the sample will tend to approximate the population standard deviation as the sample size increases. In order to calculate a standard error, you need to calculate the standard deviation. We are trying to discover the standard error and standard deviation in the height of the starting five of a basketball team in centimeters. Gina is 170.5 centimeters, Sue is 161, Toy is 160, Freda is 170, and Ty is 150.5 centimeters. The first thing we do is calculate the mean by adding the heights and dividing by the number of players. Then if we add them all together, it's 812. We divide that by the number of players, which is 5, and we get a mean of 162.4. We then need to find the deviation, and we do this by subtracting the mean from all the heights. So we subtract 162.4 from 170.5 and get 8.1, and on down the list. The next step is to square all the deviations and add them together. And we do that. And when you multiply something times itself, you get it takes out the negative numbers. Negative number times a negative number is always a positive number. So we're multiplying negative numbers times each other, and then we're getting a positive number. And it turns out to be 272.7. We will now find the standard deviation of the starting five by taking the sum of the deviations squared, 272.7, and dividing by n minus 1, where n is the number of units we have, 5. And of course, that we'll divide 272.7, we'll divide it by 4, and that'll give us the standard deviation. So the standard deviation in this case, or not the standard deviation, but that'll give us the next figure, and that's 68.175. To calculate the standard deviation, we'll take the square root of 68.175, and that will be the standard deviation. In this case, it's 8.257. The standard of error is the standard deviation, 8.257, divided by the square root of the sample size. The sample size is 5, and the square root of 5 is 2.236. The standard error will be the standard deviation, 8.257, divided by the square root of the sample size, 2.236, which is 3.693. So the standard deviation is 8.257, and the standard error is 3.693. If each player were the same height, the standard deviation would be 0. The larger the sample, the closer to 0 the standard error becomes, because it makes the outliers less mathematically important. And if we notice, we have the difference between Freda and Gina are 170 centimeters tall, but Ty's only 150. So that's a difference of 20 centimeters. That's quite a difference. A confidence interval is how much uncertainty there is with any particular statistic. Confidence intervals are often used with a margin of error. It tells you how confident you can be that the results from a poll or survey reflect what you would expect to find if it were possible to survey the entire population. Confidence intervals are intrinsically connected to confidence levels. A confidence interval for the mean is a way of estimating the true population mean. Instead of a single number for the mean, a confidence interval gives you a lower estimate of an upper estimate. For example, instead of 6 as the mean, you might get 5 or 7, where 5 is the lower estimate and 7 is the upper. A normal curve is a theoretical distribution of a great significance in the field of statistics. And we're talking about normal curves right now with the coronavirus. We were talking about lowering the curve, lowering the curve. What we were trying to do, we were trying to reduce the number of people that had the disease. Is what we were trying to do. But unfortunately, the very opposite has happened. Instead of lowering the number of people that have the disease, it seems to be going up all the time. So either we're still in the first wave of this thing, or we erred. We made a mistake. This is especially true in Arizona. That when the coronavirus first hit Arizona, it was mainly wasn't in Phoenix, and it wasn't so much in Tucson or Flagstaff. It was on the reservation, and of course, some people got upset about that, and some people just kind of ignored it. But then it spread to Phoenix, and it spread to Tucson. Well, one of the things about the reservation, all the people on the reservation are kind of spread out. And since you guys are so spread out, you didn't really have to worry about a lot of people catching the disease because you were already sheltering in place. But people in Phoenix live really close to each other, live on top of each other, they live really close to each other. So the biggest problem that people were having, or are having now, is the fact that they can't get away from the disease. If you live on the reservation, you just go home and stay in your house. If somebody gets sick in your house, you let that person stay in the house, and everybody else moves out, and that keeps everybody else from catching the disease. But when you live in Phoenix or Tucson, and you live in an apartment building, and somebody on the bottom floor catches the coronavirus, everybody that walks past their apartment potentially can catch the coronavirus. And since there were so many more people there, of course, now it's exploding in Arizona. The normal curve, if a given sampling distribution is known to be approximately normal, we can infer that about 68% of the sample estimates and it comprises will lie between its mean and one standard deviation, and about 95% between its mean and two standard deviations. And of course, when I was talking to my son about figuring all this stuff out, he multiplied it all out, and it made a lot of sense to him because one standard deviation was about 68%, and two standard deviations included just about everybody, 95%. Estimating the size of the sample to be drawn, recall the formula for the standard error of the mean. Standard error equals S over the square root of n, where S is the standard deviation of the variable under study, and n is the sample size. Inverting this formula, we then have the number equals S squared over the squaring the standard error. If the sample size turns out to be too large relative to the population, the finite population correction is added. In this case, n divided by n is the sample size divided by the population size is added to 1. The final sample size is thereby calculated as that formula. Decisions concerning the sample size. First, researchers must decide how precise they want their sample results to be, how large a standard error is acceptable. Second, they must decide how the results would be analyzed. Third, if more than one variable is being examined, the researchers should decide whether a sample size is satisfactory for one variable is adequate for the other variables. Sampling theory is concerned with the error introduced by using a sampling procedure. In survey research, the most common error is non-response errors. Non-responses are defined as observations missing for reasons such as the refusal to be interviewed, an individual's absence from the home, and misplaced forms. Non-response can introduce a substantial bias in the findings. The amount and kind of bias is related to the following conditions. The greater the rate of non-response, the greater the bias introduced. The response rate can be calculated as follows. There's where R is your response rate and N is your sample size. The seriousness of the bias depends on the extent to which the population mean of the non-response stratum in the sample differs from that of the response stratum. In other words, if you have if you have more non-responses than responses, now you got a problem. Each of the following types of non-response influences the sample results in a different way. Uninterviewables, so people who are illiterate or have language barriers. Not found, people who have moved or are inaccessible. Not at homes, people who are out when the interviewer calls but are reached later and their responses are subsequently added. Refusals, people who refuse to cooperate or to answer all the survey questions. And that is the end of chapter 7 and 8. Now we will start on chapter 9. Observational methods. In social sciences, information is obtained in either formal or informal settings and using either verbal or nonverbal methods. These combinations create the four major methods of data collection. Four major methods of data collection: observational methods, survey research, personal interviews and questionnaires, qualitative research, and secondary data analyses, such as the analysis of existing documents. Triangulation is the use of multiple methods in a study to see if the findings that emerge from each will converge on a common conclusion, thereby increasing the validity of the result. An example, a survey might be supplemented by an interview. If the findings obtained by the different data are consistent, the validity of the findings increases. Politically, we can say if we interviewed somebody and they said that Roger Stone, who was he had his sentence commuted, if Roger Stone actually interviewed Russians, if we found a document that said that, we could go to Roger Stone and we could ask him, hey, did you interview Russians? At this point, he would probably say yes, bwahaha, but you can't try me for the same thing twice. Each of the four major methods of data collection has certain advantages as well as limitations. To a certain degree, all research findings are affected by the nature of the data collection methods and assumptions used. Artifacts, findings that are strongly affected by methods and assumptions rather than the empirical facts. An example in the 50s with the birth of the TV research showed that observing violence could cause violent behavior. While it may be true in the 50s and 60s, this concept may be an artifact today, since we see so much violence on television and in our video games and at the movies. Research in the social sciences is rooted in empirical observation. Examples: political scientists observe the behavior of occupants of political offices. Anthropologists observe rituals in simple rural as well as complex urban societies. Social psychologists observe interactions in small groups. In a sense, all social science research begins and ends with empirical observation. Modern social science is rooted in observation, and this technique of studying behavior has a number of distinguishing characteristics and/or advantages. For one thing, it is direct. It takes place in natural settings. It allows the study of people who cannot or will not report their own behavior. It invites comparison of verbal reports and actual behavior. It facilitates analysis of the context in which behavior occurs. The main advantage of observation is directness. This enables researchers to study behavior in real time as it occurs. A researcher does not have to ask people about their own behavior and the actions of others. He or she can simply watch them act and speak. This enables the researcher to collect data firsthand, thereby preventing contamination or distortion of the data by factors or events standing between him or her and the object of research. An example, when people are asked to report their past behavior, distortions in memory may influence the findings significantly, whereas the memory has no effect on the behavioral data collected through observational methods. So if you observe somebody doing something, they always did it. They may not remember they did it, but you observed it, therefore you know that it happened. Observation describes phenomena as they occur in their natural settings. Observation demands a lower level of activity involvement from those being studied compared to verbal reports, which includes children who tend to find it difficult to be introspective, qualifying day-to-day encounters as more than just good or bad, observing individuals who are unwilling to express themselves verbally. Men have a hard time expressing themselves verbally. Through observation, researchers can validate verbal reports by comparing them with actual behavior. Finally, because the relationship between an individual and their environment is not altered in studies using observation, the researcher can detect the impact that the environment has on the persons being studied. This facilitates analysis of the contextual background of the behavior observed. Observation is a suitable method for a variety of research purposes. In exploratory research, in order to gain insights that will subsequently be tested as hypotheses, when collecting supplementary data for interpreting or validating findings obtained by other methods, as primary methods of data collection and descriptive studies. Researchers must answer 4 major questions to ensure that the data obtained are systematic and meaningful. What will be observed? Where and when will the observations take place? How will the data be recorded? How much inference is required? Observation requires operational definitions. The operational definitions will determine how the variables will be measured based on nonverbal behavior, spatial behavior, linguistic behavior, and extra-linguistic behavior. Nonverbal behavior is defined as the body movements of the organism and consists of motor expressions that may originate in various parts of the body. Nonverbal behaviors have been proven to be valid indicators of social, political, and psychological processes experienced by individuals and groups. Facial expressions in particular convey a whole range of emotions, including fear, surprise, anger, disgust, and sadness. Spatial behavior refers to actions taken by individuals as they structure the physical space around them. For example, people can move toward or away from a person or object. They can maintain closeness or distance in various contexts. Violations of personal space frequently produce stress, a condition in which people report feeling tense and anxious. The outcomes of stress lead to physiological symptoms, changes in galvanic skin response, pulse rate, blood pressure, and so forth. Scientists can use behavior as indicators of culturally determined spatial norms in a number of physical settings, such as crowds. Researchers must be acutely aware of cultural differences when it comes to spatial behavior. There is a distinct pattern in the way that people use the space immediately surrounding them when they interact with others. Cultural variations in personal space can have significant implications for behavior in culturally diverse cities and societies. Good example, when I was in the service, one of the places that we visited was Amsterdam. While I was in Amsterdam with my children, I got the feeling that people were trying to push me into the canals. In other words, they were too close to me. I could feel that the Dutch and the other people in the city were closer to me than I wanted them to be. And for that reason, I kept trying to move away from them. When I tried to move away from them, I moved closer to the canals. And because of that, I got the feeling that they were trying to harm me and my children. And it all had to do with spatial behavior. Their spatial behavior was different from mine. They didn't mind brushing up against somebody. As somebody from Indiana, somebody who's an American, somebody who is from Indiana, I didn't want them to be that close to me. And for that reason, of course, we kind of had a problem. South Americans have narrower personal spaces than do North Americans, Germans, and the English. And of course, I had been in Germany. I was stationed in Germany, so the Germans do have a large personal space. So do the Brits. But here I was in Amsterdam. A lot of these individuals were not. They weren't Dutch. Some of them were Africans. Some of them were from Eastern Europe. Anyway, they weren't the same, and they didn't have the same ideas. Individuals from German and Argentinian backgrounds may find it more difficult to interact with one another because each has difficulty establishing a satisfactory interpersonal space with the other. Kind of funny, if you remember, we used to have a professor who was Canadian, and Canadians have a large personal space. Of course, I'm from Indiana. We would talk to each other. We'd talk to each other from across the room, and that was as close to each other as we wanted to get because she had a large personal space and I had a large personal space. And if either one of us got too close to the other one moved away. It was really kind of interesting to watch this curious dance that we had. Linguistic behavior refers to words, the manifest content of speech, and the various attributes of verbal communication. Extensive use of measures of linguistic behavior has been made particularly in studies on social interaction. Extralinguistic behavior or paralanguage, words in themselves make up only a small portion of the linguistic content of behavior. The non-content aspects of verbal behavior, such as the rate of speaking, loudness, the tendency to interrupt, and pronunciation peculiarities, constitute a fruitful source of data. The concept of body language refers to essentially the same phenomena. The average duration of spontaneous speech increases as the size of the group increases. The frequency with which one person interrupts another reflects differences in personal power. The more powerful you are, the more you interrupt people. Trump will do that all the time. He interrupts newsmen that are trying to ask him questions. People express passive emotions such as sadness through slow, muted, and lower pitched speech. They communicate active emotions such as anger by fast, loud, and high pitched speech. Another set of issues influencing when to use observational methods concerns the timing and recording of the observations. Time sampling is the process of selecting observation units, specific points in time at which to make observations. Time sampling ensures the representativeness of the ongoing activities observed, otherwise known as the defined population of behavior. Individual sampling or specimen records. In individual sampling, the researcher selects one individual and records all the behavior and events experienced by that individual during a specified period of time. That's individual sampling. For example, when studying classroom aggression, the researcher might choose one child and record all instances of physical aggression between that child and other classmates for a period of 30 minutes. Every 30 minutes, a different child would be selected and observed. All the observations collected, the total data set, would then represent the behavior of the entire class. A coding system is required for recording the observations. Researchers must categorize and assign a code for each category. A coding system can be constructed by applying either a deductive approach or an inductive approach. Deductive approach, the researcher begins with a conceptual definition. Deductive approach specifies indicators of the behavior to be observed. Deductive approach then standardizes and validates the resulting instrument. The deductive approach, the observer assigns the observations to predefined categories at the time of observation is recorded. The inductive approach requires a researcher to select indicators at the first stage of data collection and to postpone the construction of conceptual definitions until a pattern is identified. Each approach involves some risk. When using the deductive approach, it is difficult to foresee whether the conceptual definition is sufficiently precise. The inductive approach poses difficulties in interpreting observations. Remember, with the inductive approach, you categorize things as you see them. With the deductive approach, you've already mapped out everything that you're looking for. The ideal way to reduce these risks is to combine the two approaches. Categories in which observations are assigned must exhibit certain characteristics. They must be explicit. They must be exhaustive. They must be mutually exclusive. Degree of inference. Most observational data collection methods involve some degree of inference. When observing a certain act or behavior, the researcher must infer whether the behavior indicates the variable being investigated. Some observations demand a low degree of inference from the observer. Many acts, however, require a greater degree of inference. The reliability of the inference depends on a large extent to the competence of the observer. Two general types of observational methods, controlled and non-controlled. The two are differentiated by the extent to which decisions regarding behavior, timing, recording, and inference are systematically and rigorously implemented. Control observation methods are characterized by clear and explicit decisions made as to what, how, and when to observe. Those are control observations. Non-controlled observations are considerably less systematic and allow for greater flexibility. Those two ladies look alike, but they have the same outfits on. But they have different shoes on. Control observation can be carried out in the laboratory as well as in the field. In both settings, scientists wish to maximize control over extrinsic and intrinsic variables as a means to support the inference of causality. The most highly controlled method of data collection used in the social sciences is laboratory experimentation. Laboratory experimentation involves the creation of a controlled environment in the laboratory where the situation's elements can be adjusted by the researcher according to a set plan. Laboratory experimentation permits simulation of certain features of a natural environment along with the manipulation of one or more elements, the independent variables, in order to observe the effects produced. Experimental realism is an experiment that is realistic if the situation is experienced as real by the research participants. Mundane realism is the extent to which events taking place in the laboratory setting are likely to occur outside it in the real world. An experiment high on mundane realism and low on experimental realism does not necessarily yield more meaningful results than one that is high on experimental realism and low on mundane realism. Laboratory experiments, there are three potential types of biases. Bias due to the demand characteristics of the experimental situation itself, bias due to the unintentional influence of the experimenters, and measurement artifacts. Bias due to demand characteristics may occur when individuals who know that they are in an experimental situation and who are aware that they are being observed believe that certain responses are expected of them. A lot of people, when they take surveys, they try to determine who the people are that are asking for the surveys, and then they try to answer them appropriately or inappropriately, whichever the case may be. Responses to the experimental manipulation may reflect the participants' interpretations of the behavior the manipulations are intended to elicit. A commonly used term for this sort of bias is desirability bias. In other words, that's just what I said. They try to determine who you are. They try to, and it's a trick. It's a surveying trick that you use attractive young people to get these results. If you're looking for positive results. Because the individual taking the survey will try to play up to that individual. The more attractive they are, the younger they are, the more likely that they will, desirability bias will be in place. Bias due to behavior of the experimenter, the experimental expectancy effect. Researchers may unintentionally communicate their expectations regarding the participants' behavior in various ways, such as showing tension or relief, nodding when certain responses are made. Bias in measurement. Measurement procedures may produce bias into the data by giving hints about the true purpose of the experiment. These hints may operate in a manner similar to the experimenter bias or demand characteristics. Measuring instruments may be reactive in that they may alter the phenomenon being measured. Timing of measurement may also lead to misleading results. A field experiment is research which takes place in a natural environment. In a field experiment, the investigator manipulates one or more independent variables under conditions that are as carefully controlled as the situation permits. The difficulties involved in controlling intrinsic and especially extrinsic factors are considerably greater in field experiments. Field experiments, the strength they permit investigation of complex interactions, processes, and change in real-life natural situations. Their weaknesses lies in the area of control. Researchers cannot control intrinsic and extrinsic sources of validity as systematically in field experiments as they can in laboratory experiments. And of course, ethical issues are also of concern. If you're observing how many people pinch tomatoes and you're just standing there watching them, is that ethical or is that unethical? You didn't tell them what was going on, you're just observing them. Pilot studies or test runs or pre-tests of the experiment that enable the investigator to ascertain whether the research participants or any other aspect of the research design are likely to differ systematically on any relevant factors other than their responses to the independent variable. Ethics of field. Oh, I should have warned you about this. These are people standing around in their underwear for some reason. That's an experiment they did up in Canada. It's really kind of bizarre. Of course, the pretty people are all up in front. Yeah, pretty much. The participants in field experiments are often unaware that they are taking part in research. Of course, these people are. They've got their clothes in bags and right below them. The social scientist has to ensure that the privacy of the affected individuals is not violated and that they are protected from undue embarrassment or distress. Evidently, none of these people are distressed. I can't see anybody that's distressed. They've all got something written across their chests. Well, maybe, I don't know. I have no idea. Anyway. Natural experiment is exactly as it sounds, an experiment carried out in an environment that has been manipulated by the experimenter. Relative to laboratory experimentation and field experiments, the key difference is that the manipulation of the environment is naturally occurring. And that is the end of this lecture. So I hope all of you are staying safe. I hope your relatives are all healthy. I'm sheltering in place primarily. I rarely go anywhere. So I'm okay. So all of you stay safe. I always love my students. So I'll see you next time.